Okay. Automatic announcement always catches me out. Well, a very good day to one and all, and a formal welcome to the 2021 G-QRP Virtual Convention. It's the second virtual convention that we've run. I've lost count of how many conventions generally we've done, but fingers crossed next year we will be back to physical meetings. But in this brave new world, absolutely 100% committed to keeping these channels open. So even if we've got live talks going in Telford, I'm sure we can arrange a live stream and likewise have streaming speakers in from other parts of the world, because it just seems to work so well. So thank you to one and all, and thanks to everybody who's made this happen. I'm the chairman, and I try and sort of act as ringmaster to keep it all in check, but everybody's played a part, and I'm sure as the weekend goes on, it will be equally successful as it was last year. And we are 33% plus increase in registrations. So that to me is a pretty good endorsement that what we did last year was about right. I see we've got over 200 people on the call just now. Obviously the 700 are not all going to be in place at all the same time, thank goodness. But even if they are, we have the facilities, everybody should be okay. So I've not got anything else to say really, so I'm going to shut up, and I'm going to pass over to Nick, and then I think on to Neville to get the first session going. So any finals from you, Nick?
Yeah, just to get Bill, G4ERV, to introduce himself. He's going to be hosting over the weekend as well. Bill, over to you.
Okay. Hello, Nick, or hello, everybody. Yeah, I'm here, willing to help, and no doubt see you through the weekend. Thanks.
Brilliant. Thank you, Bill. Okay, on that note, I'm going to hand over to Neville to take the microphone and to introduce our first speaker, Charlie, ZL2CTM. Over to you, Neville.
Thank you very much, Nick. Nick, can you just enable screen sharing for me, please?
You should already have it, but I can do it for you.
Yeah.
And me too, please. It's disabled.
Is it? Okay, right. I'll sort that for you. Just hold on 1 second. Okay, that's done.
It is too. Thank you. Right. And thank you, Nick. And good evening from down under. And greetings to you and whatever your time zone is. My name is Neville, and it is my great pleasure to introduce to you a New Zealand national treasure. And I suggest international treasure in the world of homebrew QRP. And of course, I'm referring to one Charles Timothy Morris, a ZL2CTM. Charles will be familiar to many of you because of his YouTube channel and his blog. His first video was uploaded in February 2016, and in the past 5 years, he's uploaded more than 250 videos, which have been watched more than 670,000 times. More than 5,000 friends have subscribed to his channel. A few weeks back, I gave Charles a call and broke the bad news to him. I'd drawn the short straw and was to introduce him to the conference. He was unfazed by this. He said he'd forward me his bio, which has everything I'd need to know about him. He was right. It was a comprehensive document of several hundred pages. It had everything from his birth certificate, primary school learn to swim certificates, his full service record, 30 years in the New Zealand Air Force. The list was endless. Then I had a brainwave. If I want to get to the truth of who Charles is, don't ask him, ask his wife. She'll give me the dirt on him. And so she did. Apologies in advance, Charlie. And here's Charlie. Clearly from an early age, clearly been somewhere he shouldn't have, no doubt satisfying his inquiring mind. Apparently, at age 3, he hid in the cupboard with an electric heater and tried to pull it apart with a spoon. One hopes the heater wasn't plugged in. Of more recent times, the family purchased an espresso machine with a warning on the machine: do not dismantle when hot. For Charlie, that was a coded instruction to do exactly that: open when hot. His wife told me the released pressure blew Charlie clean across the room. He's also blown up a few home appliances while trying to see how they work or make them work better. Charlie's forgiving wife is a star in her own right, a very accomplished triathlete and Ironwoman. Of course, Charlie, being her biggest fan, goes to all the events. It doesn't take long for Charlie to work out what comms the officials are using, and he tunes in on one of his radios to get all the inside info. One day, Charlie decided it'd be a good idea to get some sort of GPS tracking device for her, so he'd know where she was on the circuit and could be ready at transition points for her. With this bright idea in mind, he marches into an electronics store with his dear wife and explains to the salesperson that he wants to keep track of his wife's every movement, and do they have something that he can strap to her ankle or wrist. The salesperson gave the couple a very strange look as they quietly exited the store. Not to be deterred, Charlie went and built his own GPS tracker, which still works perfectly today. Charlie's interests, other than radio, are tramping, or as some say, hiking, and flying. He holds a private pilot's license and is a mad keen paraglider. As I now hand over to Charlie, he'll no doubt say what he always starts his videos with: "G'day, Charlie here. Apologies for not." He's always apologising for something and I have no idea why. This is not a tutorial. I am in no way, shape or form an expert on any of this. Yeah, right, Charlie. I acknowledge this is not the best way, but it works for me. Well, Charlie, the floor is yours. We'll accept no apologies, and we'll all watch and listen to your best practice expert tutorial and in awe of your knowledge and skill. Take it away, buddy.
Well, thank you very much for that. Let me turn this sharing on. Hopefully, fingers crossed, you'll see a presentation come up. How's that? Is that up now? Just confirming that's up?
Yes, it is.
Perfect. Thank you very much. Well, firstly, thank you very much for the conference organisers for arranging this in what are very trying times. As I sit here in New Zealand, I'm currently in lockdown, level 3 for us. So yeah, very trying times, and I certainly hope that everywhere around the world's staying safe. It was an interesting comment before about ungodly hours around the world that people are up at. I'm quite used to that. The job I've actually just left, the New Zealand Civil Aviation Authority, I used to sit in quite a bit on the international standards development organisations, and would frequently sit in on meetings starting at 2 o'clock in the morning, which was always very hard getting up and then off to work after that. So I do feel for you. Now, as Neville did allude to, I am going to start with a couple of caveats. And the first of which is that I am not an expert in this field. I do want to make that very clear because I don't want to come across as being an expert. I do enjoy very much the electronics, and I do want to take this opportunity to acknowledge some of the real gurus that I would say, the Pete Giuliano's, Bill Meares, Peter Parker, Farhan Usher, and the like, really, really good. And I've certainly enjoyed over the years looking at how they've approached their designs, and it's certainly influenced me, and I found it very useful. The second is when it comes to the homebrew and RF design, I guess, and construction, there's lots of different ways of approaching it. Speaking like a true regulator, what I'm going to talk about is one way. It is not the only way, but it is a way, as I've said many times in the videos, it works for me. And as I just mentioned before, I do get a lot of pleasure out of home brewing and making things. So hopefully, the videos are useful in that respect. So when I was thinking about this particular presentation, what I decided to do was talk about, I guess, how I do it. And in doing so, I'm going to sort of talk about the whole gamut. In other words, in fact, I'm going to cover this. That's the best way of doing it. Very great look at some of the background and what my current interests are, where I look to source my components from, how I approach the design, and then the building and testing, and then some of the ways which I use for enclosures, and then look at some of the other projects. Hopefully, like I say, this will be of use. It's not the only way, and like I say, hopefully it sort of encourages others to give it a go. And like I say many times in the videos, that's why I do put them up. It's to encourage others to give it a go, because as I've said many times, if I can do it, really anybody can. So in terms of background, as Neville quite rightly pointed out, I've always been interested in electronics from a very young age. I remember my parents buying way back when I was very young, just a piece of wire and a battery and a light and a very simple spade switch, which was always fascinating. I have always pulled things apart and got a few shocks in the way. There's quite a few instances where, in fact, one instance where I pulled apart a train while my parents were around, a toy train that is, at a dinner party, which didn't go down too well, and got dragged back the following day to apologise. But radios have always been a love and a fascination, sort of hearing that voice coming through the speaker through no wires. That's always been of huge interest. I was just thinking, actually, one of the things I did get up to was bugged my parents' bedroom, so that was quite interesting, working out RF that way, so that was quite interesting. Anyway, later on in life, joined the Air Force, as Neville pointed out, as an avionics technician, which is excellent. For those who've been through military training, it's very good. In this particular case, the avionics training really did provide a good insight and a reasonably good understanding into electronics, which I really did enjoy very much indeed. So that was a really good grounding there with the New Zealand Air Force. In about 1990, the neighbour of mine in the barracks, he was a keen glider pilot, hang glider pilot that is, and was quite keen for me to get my ham ticket so I could keep an eye on him as a guardian angel. So if he landed out, he could talk to me and I could arrange going to pick him up. So that really was sort of the impetus to get off and to sit the license. Back in those days, it was Morse. And after getting my license, I started with as you can see on the screen there, an FT707 with a very simple Wyndham antenna using an old AM ferrite from the coil out of an AM radio as the 4-to-1 balun, and some field telephone wire, which I managed to scrounge up. I don't know if any of you have used the field telephone wire before, but it's lethal stuff. It's got 4 strands of tinned copper and 3 strands of stainless steel, and boy oh boy, it stabs you like nobody's business. For the first 6 months, the person who taught me Morse said, once you get your ticket, put your microphone away in the cupboard and don't touch it for 6 months, which I duly did, and used that key there for the first 6 months just to sort of really hammer home the CW. So in those earlier days, did start to try and play around with homebrew, more with the sort of simple transmitters. sort of using sort of baked bean cans to house the VFOs. But it was sort of, to a certain extent, sort of flying blind. I didn't really have what I needed in terms of the test equipment to understand what was going on. So it was sort of many years later, once the kids had sort of grown up a little bit, they had the opportunity to get more equipment and to get more into it. So in terms of my current interests, I mentioned before that I really do enjoy the home brewing, mainly building simple, as you've seen in the videos, QRP rigs for the HF band. It's never my intent to build competition rigs, so I'm more than happy to live with the odd birdies here and there and the like. But it's what I enjoy. So like I say, try and encourage others to give it a go through the videos. I guess what I try to do is also have try to understand from first principles how the circuits are working, which to a certain extent I managed to work out. But that's sort of a strong desire. I don't really just want to copy circuits from elsewhere. I will if I fully understand exactly how they work, but otherwise I really do. It's just the way I guess I tick, that I want to try and understand from first principles how the circuits are actually working. Certainly enjoy the software engineering as well, so both sort of software and the hardware. So a lot of my projects will have a mixture of both. And I guess just finally, just sort of always trying to a certain extent, continuously learn and what worked well in one project, sort of carrying it through into the next. So that's sort of I guess the current interests. So setting that aside now, getting more into where I source my components before we get into the design and build. So I tend to pull apart a lot of old radios and any old bits of electronics I can sort of get my hands on. We have a term in the military, beyond economical repair, or BER. So if I deem that a radio is really just not worth it, then I'll certainly pull it apart and try and get as many useful parts as I can out of it. So that's always been a good source of some really good components. Otherwise, I source a lot of components through AliExpress and some of the other online stores, as well as brick and mortar stores here in New Zealand. New Zealand's a bit more difficult. We don't have quite the range that, for example, the United States has. So a lot of it comes through in the mail. Tend to buy in bulk, as sort of indicated there, which is, as far as I'm concerned, quite cost effective. I get sort of 600 odd resistors for $2, or say just under 1,000 capacitors for $9. So that's the way I tend. I don't sort of buy onesies and twosies. I'll just buy 100 at a time and then store them away. As you'll have seen in a lot of my videos, a preference for through-hole components. For me, that's sort of more ease of use than anything else. SMD is certainly coming along, and it's getting harder and harder to actually source the through-hole components, that is. So I will need to make that transition. And I guess Dennis was going to be talking tomorrow, now Steve, about the SMDs, so that'll be useful to listen into. And like I say, it's an area that I do need to get into, and will be getting into at some point in time. So once I've sourced the parts, there's always the issue of storage. I've tried a few different things over the years. With the resistors, what I used to have, as you can see in that sort of the right-hand side of the picture there, little plastic drawers. I used to have one drawer which was for some of the resistors, a 1-0 drawer, so 1 ohms, 10 ohms, 100 ohms, 1,000 ohms would go into that one drawer, which was great when we have the sort of 5% and 10% tolerance resistors, where you can see very easily what they are. But I find these days with the 1% resistors that they look the same one way or the other. far as I can. So either I'm doing something wrong, but I find it very, very difficult to actually just look in the box and actually say that's what that one is. So what I've now sort of switched to is have one envelope per value. So in that top left-hand corner there's a series of envelopes for resistors and a series of envelopes for capacitors, and that seems to work quite well for me. A big box of wire there. That's I try and always reuse the wire. So just normal hookup wire, and then one little plastic container for the RG174 and another container for audio cabling. In terms of toroids and the like, tend to get a range from kits and parts is where I've been sort of getting most of my toroids from. 37 or the FT37-43 for the broadband is pretty common for RFCs and the impedance or resistance matching. The 50-43 slightly larger, as well as a range of the -43 binocular cores. So sort of got quite a few of those which sit in little plastic containers. For the narrowband transformers, the more iron powder cores. For those frequencies under 10 megahertz, tend to use the red core or the -2. So the T37-2s or the slightly larger T50s or even T68s. And for over 10 megahertz, tend to use the yellow -6 core. So same size as the -6. So again, the 37, the 50, and the 68 from the core size. So try and keep a handful of those on, which is predominantly what I use. In terms of the enameled wire, what I've found has been very useful, and I'm not the only person who does this, is to use the coloured enamel. So as depicted up there in the top, sort of orange, green, and red. Must admit I'm running a bit low on the green at the moment, but when you're winding the cores, it just makes it so much easier to see which is the primary or the secondary and the like. So that certainly worked well. So for the smaller, the QRP rigs, mainly sort of number 26 and number 24 gauge for the transformers, and then for the power amplifier, sort of slightly larger, more up to the sort of the 20 and the 22 gauge. So again, sort of purchase those from the likes of AliExpress. Seems to be quite inexpensive. Takes a bit of a while to tune up, but that's sort of predominantly where we're getting those parts from. So that sort of covers off, I guess, on sort of where I'm sourcing the parts from and the approach I've taken for storage. And as you can see on the right-hand side, a couple of other shelves as well, sort of just using those plastic food containers. It seems to be quite good. Being able to sort of see in and actually see what's inside is a big helpful, rather than sort of having to open up the lid and see what's in there. So I find that quite good actually. So sort of switching gears now, I guess, into the design part of the house. The first part that I do try to do is the planning. In terms of a sequence, I look to plan, design, then build, test the modules, integrate the modules, and then do sort of final testing. So from a planning point of view, it's very much sort of what would be so traditionally the requirements definition. What do I actually want to build? It's got to be something useful as far as I'm concerned. What am I trying to achieve? What are the requirements? And then start to sort of jot down on a bit of paper, sort of a bit of a block diagram of sort of how I see this particular radio or whatever I'm building sort of fitting together, which gives the opportunity then to sort of put down gain margins, the distribution and the like, in a block diagram sort of form. The SSB rigs I've been building predominantly are single conversion, again, from a simplicity point of view, as opposed to, say, more performance. And a lot of that's what interests me. And it's also, in terms of the videos that are put up, is, again, it's a good starting point. And, in terms of encouraging others, it's a good starting point. And like I say, I certainly enjoy that. So that'll be the planning for a start. From an architectural point of view, I'm quite comfortable using a mixture of homebrew and off the shelf. So I'm happy to mix and match the two. So what would be my off the shelf? So for a VFO, for example, that would either be a homebrew VFO in a some kind of shielded container, or more than happy to buy a breakout board with an SI 5351 or an AD 9850. So either a DDS or a phase lock loop. Like I say, more than happy to mix and match those. From a crystal filters point of view, again, have done a number of homebrew filters. I've tried the more disciplined approach where working out the characteristics of each crystal, as well as just going for the more simplistic approach with the cone filter with the equal capacitances. I must admit that they both worked pretty well the same from my experience. Or I'm quite happy to use from some of those old radios that pulled apart a commercial filter. So whatever sort of takes my fancy at the time. Crystals, I actually got quite a good deal a while back. I'm pretty sure I bought like 100 odd crystals from AliExpress for, I'm tempted to say about sort of $15. It was not a lot of money for a heck of a lot of crystals. So that was sort of quite fun going through and trying to work out, you know, get a batch that was sort of within a few hertz of each other, or tens of hertz. Mixers, again, from an architectural point of view, happy to sort of mix and match with the homebrew. I think the last rig I built was using just all homebrew mixers on that one. So the one in was it 5711, I think, the Schottky diodes, or and a lot of other previous rigs, yeah, the SBL1 or the AD-1, or in some cases actually the Gilbert cells, the NE612s. It's sort of no hard and fast rule there. It's sort of just what it sort of takes the fancy. But again, sort of happy to mix and match. I'm not sort of hard over, you know, one way or another. As I mentioned before, quite keen on the first principles, so sort of trying to work out the maths in the designs, which is interesting. Sort of acknowledging that the maths will only get you so far, and sort of once you've then started to build the circuit, then there's a lot of tweaking that's needed. But you know, I'd always sort of want to try and start at least trying to do the numbers and then going from there. I guess I'm not quite sure if that's a throwback to the Air Force days, but that's what I enjoy anyway. I tend to use readily available parts, as I think I've mentioned a few times on the videos. For example, you know, the 2N3904, or you know, the RF510, or the BD139. And my thinking there is, again, in terms of trying to encourage others to give it a go, it's if you sort of stick with the cheap and cheerful and the readily available parts, then you know, hopefully others will give it a go. So that's sort of pretty well where I'm at. Sort of very sort of, yeah, like I say, common off-the-shelf components. In terms of research, so sort of once I've got the idea of what I want to build, and sort of the architecture that I want to throw into it, it's then sort of into a lot of research. So experimental methods for RF design I use a lot, as well as a solid state design for the radio amateur, so the 2 books up there, as well as an old G-QRP book there, which goes back several years. The textbooks are good, lots of good sort of explanations, but what I find with a lot of the textbooks is there's not the maths, which is what I'm sort of craving for, which is a bit frustrating. I haven't really found a good source of reference books which sort of go into the maths. University textbooks are okay, but that's sort of more describing the world from a mathematical point of view, as opposed to one sort of level up into what I'm trying to do here. And you know, this is an amplifier, this is how the calculations are done, this is, you know, the biasing resistors, this is the determinations, or how they're determined more to point, which is a bit frustrating. Tend to stick with sort of simple configurations. For example, a common emitter amplifier for the amplifiers. a little bit of, that's what I'm sort of used to. It's sort of comfortable with that more than anything else. So not afraid to use something else, but at the moment it's sort of just more sticking with the more sort of generic amplifier designs. Do tend to use quite a few of the online reference material on the internet. So, for example, toroids.info, which is really useful, that I use a lot for toroids. There's some really good websites out there, and just sort of handy little tools that people have written for attenuators, for bandpass filters and the like. So you're not afraid to sort of use those where needed to sort of help out. LT Spice is another really good tool, a free tool, which I try to use at least to sort of have a look at the initial design just to see what it may look like. Generally speaking, it's been quite good in terms of what it predicts versus what I actually see at the end with, for example, the oscilloscope. So that's a good tool, and I'd certainly recommend that, you know, if people were to get more into this, to give that a go. Tend to do a lot of prototyping where I can. So for the low frequency work, you know, audio and sort of some of the digital work, we use sort of the breadboard just to I guess test the circuit before committing it to, or turning on the soldering iron, more the point. Not so good for radio frequency, the breadboard, because of the straight capacitances and the inductances, it just doesn't work very well. But for, like I say, for the audio and the switching side of the house, it works very well. It's only then at this point that I elect to turn on the soldering iron and actually start to make something. So from a tooling point of view, a lot of simple tools. So nothing sort of exotic here that I use in the shack. I spent 4.5 years over in Texas, and took the opportunity to buy a nice Weller soldering iron there. So it's 115 volts, and I've got a transformer, but it's a good temperature controlled soldering iron is certainly useful. The tools themselves, from left to right, I guess, pair of tin snips, which I use for cutting the copper board, and that'll become apparent later on in the presentation. So I use that. We've got a little solder sucker there, diags, as well as a pair of flat nose pliers, which we'll see in a sec. Some wire strippers, some automatic ones, which I've had for a long time. That's my second pair. The first pair went for 30, no, more than that, about 40 odd years, which is great. It's really good. They don't nick the internal conductors, always strip off the outer insulation. Work really well. Standing knife here, which we'll see later on for cutting the strip board, as well as the drill, which we'll see later on, and a little pick there. The solder, I don't know where I got this from and why I started doing it, but that particular little black object there is a film canister, and that one is a really old one, which I just pop the top off, you get the spindle out, and you just wind on the solder, put it back together, and you've got a nice self-contained solder dispenser. Just pull out what you need and use it. That's nice and easy, which works out really well. And then the solder wick there, again, inexpensive solder wick that I get them through AliExpress. I use that for two reasons. Sometimes for actually desoldering, but what it's more used for is I soak it with solder, and as you'll see later on, use it for mounting tabs for the modules. It works certainly very well. In terms of meters, got some pretty simple meters there. The LCR meter on the left-hand side, again, quite inexpensive, that I got through AliExpress, and for my purposes, it works just fine. Been more than happy with that. In terms of meters on the right, that middle one I've had, gosh, for 30 odd years as well. It's an old meter which sort of keeps going. Sort of replaced it with the Fluke, but it's got quite a nice useful feature there, which I use from time to time, which is the DC HFE on or the DC current gain on a transistor, which is quite useful. But also actually using it as just a transistor tester to see if things are working or not. So yeah, other than that, we'll get into test equipment later on. But in terms of meters, that's all I have. Like I say, just the LCR bridge just to confirm that what I've got is actually what I want, and then the other meters for current and for voltage. RF voltage, I just tend to use the oscilloscope. I don't have, well, I do have, but for whatever reason, I don't really use it. An RF probe for probing voltages, I just tend to use the oscilloscope for that, right or wrong. So in terms of the modules, I do build in modules. So the block diagram may have an input bandpass filter, then into say an IF amplifier, and then the mixer, not that sequence, but they will become modules as you see there. And what I have been using for quite some time now is stripboard. I use that stripboard upside down. I'm not quite entirely sure why I started doing that, but it's an approach which unorthodox, but it works for me. So in terms of, what's the best way of describing this? The circuit is left to right. So for an amplifier, with the base side of the house will be on the left-hand side and the collector on the right. In terms of the actual lines or the rows themselves, the bottom row is earth, and you'll see there, and we'll see it later on, the bottom left-hand corner has one of those little solder tabs that's been made out of the solder wick. So the first row is earth, the next row is the emitter, and then base, collector, VCC, and then another earth. I find it's quite useful having another earth on the other side, because not only does it provide another anchor point, but it's quite often, if you're got a decoupling capacitor or a need to get to an earth, that you can sort of stretch that side, not always having to go to the bottom. So in terms of actually making these, you'll see there on that picture that I'll use the flat long nose pliers to bend the legs through 90 degrees, like that, and then I'll chop them, leaving a bit of a foot. I don't chop them off square, because there is the possibility that the legs can sometimes go down the hole, which we don't want, because, as we'll see later on, this is sitting on an earth plane. So by having that little foot, it just sort of provides a little bit of support and basically stops them from going through the hole. So I'll bend them over, I'll cut them, and then I'll tin both the leads themselves, as well as the pad or the part of the strip board where it's going to go. And that approach just allows me then just to marry up the component to the board, a little bit of reheat with the soldering iron, and everything just wets and it joins up. I don't have to have two components, or the component coming to the board and then having to somehow then have a third hand and a fourth hand coming with the soldering iron. So I find that works very well. Quite conscious of sort of stray capacitances and inductance. So if I don't need the track to be full length, then I'll use that drill there just to sort of put a little bit of force down, a bit of a twist, and just cuts off or just cuts the track, which I do all the time. And like I say, to date, it's been quite successful for the frequencies that I play around with. So noting that my favorite bands, so to speak, I guess, are 80, 40, and 20. So like I say, for those frequencies, the approach works just well. Another thing you do need to worry about is the current carrying capabilities of that strip board. The copper is quite thin, but for the QRP rigs, it works just fine. And like I say, in terms of supporting these on the copper board later on, just using those that soaked solder wick to form the legs. So anyway, so I think that's all I wanted to cover off on that. That's probably the main sort of, I guess from an unorthodox point of view, way I build the components. That's again the modules. No, probably nothing much else, too much to say of that one. So in terms of the higher current and the higher power circuits, I also do use copper board. So again, pieces of copper board that I'll get in from AliExpress. In terms of making the circuits there, to date, it's been just using either a sharp edge, the corner of a small file, or a Dremel tool to cut the gaps between the tracks. I do have an engraver that I have used a couple of times, but unfortunately the house we're currently in, it's not really conducive to that in terms of setting it up. But it is something which I do want to use, and once we do shift houses, it's something which I do want to get back into. And that particular engraver there was again quite inexpensive from AliExpress. Came in a big box, built it up, and it works well. It's sold as an engraver, but for the lightweight copper boards, it works just fine. I've had no problems at all. Where I have used it, it's a matter of drawing the circuit in a simple drawing program. That then gets converted into G-code, which then goes into the software that drives the servos and the cutting head and the like. And like I say, works well. I think that's probably all I'm going to say about that one. Yeah, clearly with the wider tracks for reducing the inductance as well as the current carrying capabilities, you just can't do what you want to do that with stripboard. You tend to create a bit of smoke, which I've done before. I mentioned a couple of times now a ground plane. What has worked very well for me is using a much larger piece of copper board as a ground plane. That also acts as the DC return. So I'll pretty well lay out the radio or whatever I'm building in a way which sort of keeps some separation between modules, as well as sort of just looking nice for me. And then using those now bent down edges of the solder tab, it's just a matter of applying a little bit of solder on the board, and then they mount down, and mechanically are really strong. It's not going anywhere. You'll see in that left-hand picture there a couple of silver blobs. I have good success in reusing the board. So a lot of the bits and pieces I build will get pulled apart again and sort of reused. I've had absolutely no problems with using some 100 grit sandpaper and just basically sanding off the old solder and bringing it back nice and smooth. And I've got boards which I've used, gosh, several times over to good effect. When you do start to get a bit thin, you sort of see it around the very edges, you just start to sort of see the substrate coming through. But the large pieces of copper board, do cost a little bit. So like I say, reusing it seems a good approach. That same board there cuts up really nicely with the tin snips. So I'll also cut that up and then create vertical shields between, or on either side, for example, of crystal filter or whatever. And then just a matter of at the base of that, just a couple of blobs of solder with the soldering iron just to melt the solder between both the vertical and horizontal parts. And some very effective shields can be made, very simply, just using that same copper board. From an interconnection point of view, I stole an idea from Pete Giuliano, so I do try to use orange hookup wire for receive circuits and yellow wire for those that are involved with the transmit, and then using brown wire for both transmit and receive, and white for digital switching or the like. It just makes it a whole lot easier when you're sort of then looking at the radio or whatever you've built to sort of understand that, okay, well, that part there is part of the transmit side and that part's the receive and the like, as opposed to it's all one color and you're trying to work out and with what is what. So thank you, Pete. That certainly worked well for me, and I'm going to continue using it that way. In terms of the shields on the cabling, so for the RF, the RG174, I tend to earth the shields at both ends, and that's pretty well, in fact it is most of the time, directly onto the ground base shield. For audio, I just go at one end to try and minimize the earth loops. From a VCC point of view, for the various voltages, sort of have a star connection back to one point. So a common earth return, but a star point back to the 12 volts or 5 volts or whatever. Seems to work quite well. Not an expert when it comes into really the understanding the noise from earth loops, but that approach has worked quite well. And like I say, I've got away with the radios I want to build and with not too many problems with instability. What else? We'll see later on some mounts of bits and pieces, but gosh, a bit windy out there. But that's it, yeah. So like I say, that ground plane is really useful, and with the module sitting on top of that, I very rarely have instability problems. Where I do, it's more with the blackout of the power amplifiers, and just a couple of extra little earth tabs fixes most of the problems I have there. But generally speaking, the rest of the circuits work really well with that approach. So I'll continue doing that one. When it comes to RF switching around the circuit, I mainly use relays, and that's mainly because of the simplicity of them. That relay in the middle there, that's the one that you traditionally see switching both the high current supply line to the power amplifier as well as your the RF or the antenna switch, for example. You know, that's $1.46 from AliExpress, New Zealand dollars. So really inexpensive. The other ones are cheaper than that again. So I tend to use relays quite a bit. Some of those, for interest's sake, are sort of digital logic control ones there. For example, on that left-hand side, it's provided with 5 volts, and then a logic low will turn the relay on and off. And those have been quite successful for sort of the Arduino-driven circuits, just to drive a digital I/O pin directly to that, just to switch it on and off. So yeah, they were very inexpensive. So I've been sort of playing around and using those, which have been good. Most of the relays are double pole, double throw. I've also used, you'll see in some of those rigs, 4-pole double throw switches, you know, a big beefy switch, which sort of acts as both the PTT switch, as well as on the back of it switching the RF and the 12 volts between the transmit and the receive circuits. So like I said, that's what I predominantly use. There was an experiment I did a while back looking at diodes, your diode switching, which sure, it worked, but I just felt that, you know, the extra complexity to have the inductors and the capacitors for the DC isolation and the RF coupling sort of outweighed the simplicity of having just a relay. So, you know, it's not the right way, it's a way, it's a way that I use, and it works fine for me. In terms of user or operator input and output, The radios tend to use just very simple approaches. In fact, all of my projects are very simple. So just very inexpensive switches there. Most of a lot of those there are double pole, double throw. I buy 30 at a time from AliExpress for a princely sum of $2.50, free shipping to New Zealand. So I've got plastic containers behind me just full of those, which makes it nice and easy. So buying in bulk certainly works. Rotary encoders mainly because I predominantly sort of use a digital VFO. Yeah, that's mainly what I use. That bottom rotary encoder there, again, very inexpensive. The center, gosh, it's a push button switch as well. So that's quite useful. Gosh, got a bit tongue-tied there. On the right-hand side, some screens. I've tried all sorts. Very much stick for just simple screens because the radios themselves are simple. I'm not having the ability to change IF bandwidths or other parts of the radio. There's really no need to display. Well, as far as I'm concerned, there's no need to display too much. So the screens tend to be very simple. So be it a 16:2 LCD or some of those small 0.96 inch OLEDs. One of the radios just had a blinking LED telling me what the frequency was, or some of those inexpensive, as you can see there, LEDs. They just work just fine. Again, predominantly purchased from AliExpress for not a lot at all. I mentioned before making brackets and the like. So again, that same copper board that's used for the bass or used for the PAs, just again with the old tin snips there, just cut it into simple structures. You might be able to see there the solder that's used to hold those together. And just for the traditional use of a few gussets here and there to make them nice and stable. That's what I predominantly use for securing switches, volume controls, whatever. And then as you'll see later on, they just then screw directly into the breadboard. So I have those for antenna, the PL259, plug on the back. That'll also mount into a bracket like that. So again, simple, easy, quick to use. It's not everyone's taste. I totally understand that. But very much function over form, and for the types of radios that I enjoy building, it works just fine. I mentioned before software engineering. I've done a reasonable amount of that through the training over the years. Sort of started with the PIC range, and then more recently using the Arduinos. And as everybody else, I'm sure is well aware, it's very inexpensive. Mainly use the Pro Mini and the Nano, those two smaller ones at the bottom for the tramping rigs. Just nice and small. And then the Mega and the Uno for the base rigs, where sometimes I sort of play around with a few more requirements or needs for I/O, and the Mega in that example there provides a whole lot more. I do just use the stock standard integrated development environment, the IDE, that comes with the Arduino. It works for me. Have absolutely no problems using libraries, so libraries that other people have built. Sort of tend to find one which I like, and then what I'll always do, because libraries are the biggest cause of headaches when you give someone else your code, I will keep a copy of known good libraries in a repository on my computer. So I always know which is which and what was where. So I find that very useful. And if I have to rebuild a machine, then I just copy across the known good libraries, and off we go. Because I do tend to reuse software modules between projects. Yeah, if it's going to be a radio and they both require a VFO, then I'll just reuse the code. So it's certainly useful to reuse, or imperative really, to reuse the libraries. The approach that I take with the software that I like to use is the equivalent of the old Hello World. So if I'm driving some new piece of hardware, I will start with the example that comes with the library, and then really understand how that works. Pair it right back, get rid of all the bits that does not require, get right back to the core code, understand how that works, integrate that into the main project, and then just iterate. So what I tend to do with the software is start small and just add functions, make sure the function works, add another function, make sure that works, add another function, and on and on. I find that's a whole lot better than trying to write the entire program in one go, compile, and things don't work, and you try and work out what the heck's going on. So that sort of spiral development approach has worked and continues to work for me. So it works well. For some of the software-defined radios, I have played around with the Teensy. It's got a very capable ARM Cortex processor, and the audio library that's been developed to support that platform is really very good, as far as I'm concerned. Really good for digital signal processing. So yeah, I've got a couple of Teensies there which have the audio board underneath. And it's quite a straightforward process then to bring in audio from the hardware point of view. It's digitized, it's in software, you can muck around with it, and then spit it back out as analog. And like I say, the audio library is pretty straightforward, and some really good examples out there. So yeah, I use those from time to time for some of the projects. Other than that, in terms of the hard drive, just sort of try and keep a good folder of software development. So as you'll see later on, there's clocks, there's radios, test equipment or whatever, and then sitting under that will be the various projects. So it's just nice and easy to find them in the future when you need to go back, and invariably you do. So that's pretty well the finishing off the build, which then takes us into the test. So as I mentioned before, tend to design the module, build the module, test the module, and then once all the modules together, integrate them together, and off we go. So just want to sort of, I guess, touch on some of the bits of test equipment that I have in the shack here. Like I say, the aim is to test each module after the build. As far as I'm concerned, you don't need high-end test equipment at all. As we'll see later on with Tony Fishball, he's got he'll be looking at, I think later on in the program, building some RF test equipment, which will be certainly useful. Again, this is just the approach that works for me, and like I say, it's been good. So I've got a power supply there as a start. You need to have power for your projects. This one here I have had for a long time. What I like about this particular power supply is it's variable, so which allows me then to play around with both 5-volt circuits, 12-volt circuit, 13.8, whatever, and vary things in between. So that's certainly useful. And the other one which I found very useful is it's got the short circuit protection. So there have been a couple of times where I have short circuited a few things, and it's just nice that the magic smoke's not released and it's actually protected by this. I also got a couple of SLAs, the old motorbike batteries, which I use from time to time, and then just from a protection point of view, just use a circuit breaker for that I have in series, which has also worked quite well. So yeah, that's the power supply which I use and has been working well for a long time. I've used a range of signal generators over the years, both analog and digital. The analog out the one at the top was fine. You can modulate and you have a modulated signal coming out. from my perspective, a SIGGEN is really useful, just being able to sort of test that receiver. The bottom two provide a whole lot more capability. The one on the left there is quite inexpensive signal generator that comes from, in this particular case, I got it through AliExpress again. 2 independent channels, you can modulate the channels, you can sweep frequencies, etc., etc. So it'd be quite good. The one on the right is more of a recent purchase, only because, you know, I was in a position to sort of buy some more equipment. So I thought, hey, yeah, this is a nice one. Pretty well the same functionality as the one on the left, but the user interface is a little bit easier to use. I really enjoy that particular SIGGEN and use it all the time, especially for testing amplifiers, just being able to sort of vary that input to it. If I need a stepped attenuator before that, I will have one of those, and I've got a little stepped attenuator which I do use from time to time. But being able to sweep, if I'm doing an audio amplifier, an audio frequency, being able to sweep the amplitude is, as far as I'm concerned, really useful. Tied up with the spectrum analyzer, which we'll see in a sec. I also use, from a signal generation point of view, often another radio. So I do have a commercial rig which I use from time to time, mainly for testing. So from a signal generation point of view, I'll quite often feed into the microphone of that radio a little podcast, just a little audio player, playing speech, and just have that then transmitting into a dummy load, and then just sniffing that with the receiver. And I find that very useful. And in some cases, I've set that up on the other side of the house just to get the signal down even further. So that's certainly worked out very well. And then on the flip side, having that same receiver being able to receive, which we'll see later on, has been quite useful as well. So like I say, I've certainly had good use for using signal generators, and things I didn't have when I was way back when I sort of first joined the Air Force and I was playing around there. And, you know, I was just flying blind. So having the equipment, I found these days, has certainly helped a lot in being able to understand what the heck is going on. That brings me to an oscilloscope. I really like having the oscilloscope. For me, it allows me to I'm a very visual person. I can actually see what the signal looks like. I can see if it's clean and there's no gross distortion, modulation depth and the like. I just like to be able to see the signal. I can then use that signal generation to vary it, look at the output, take measurements and the like. I had for the longest time a very simple 30 meg analog scope, which was working just fine. And like I say, I mentioned before, more recently just had the opportunity to buy another scope, and elected to go with this one here, which for me has worked out really well. That's a 200 meg scope. In the old days of an analog scope, you'd have to count the number of divisions, subdivisions, multiply that by your multiplication factor to get what you want. This is sort of a little bit cheating. It sort of does it all for you. But I do find myself just sort of also counting and just sort of double checking that what is actually telling me is from a rough order of magnitude about right, because you can get caught out. So that's the oscilloscope. And like I say, you don't have to have one, but I just really appreciate the ability to see the signal, which has been really useful. Been a lot of talk about the nano VNAs. I really like them actually, and I get a lot of use out of mine. Before I had one of these, I was using the oscilloscope for example, if I was doing a crystal filter passband, I would set up the SIGGEN, feed in a value, measure the output on the SIGGEN, and if it was the analog scope, and it was counting up the divisions, multiplying it out, putting that into a spreadsheet, repeat, rinse and repeat, rinse and repeat, and then plot out the bandwidth. As you can imagine, it took quite some time. Whereas a little device like this, as long as you understand the limitations of them, And shout out to Alan Volker, V2AEW. He's got a very good video that he's just put up in support of solder smoke, which talks about impedance measurements. So as long as you understand those limitations, as far as I'm concerned, it's a really useful piece of kit. I use it for both tuning up the antenna and looking at the antenna, as well as bandpass filters, or just filter measurements. And a couple of times actually, just sitting there, it's quite nice just being able to tweak, for example, a trim capacitor, and then watching real time the pass band change and move, which is, again, I'm a very visual person, and I find that really useful and really useful. So that's worked out really well. Another useful bit of kit, which is again really inexpensive, is the SDR. This particular one is the RTL SDR dongle. I find this one really useful to again visually see the signal in the frequency domain, and you can sort of see the modulation. And if you are looking at unwanted sidebands, it's quite good just to see if you've got a little bit of energy coming on the wrong side. Just got to be very careful of overloading of these. As you see there, I'm running two additional filters with that. One to block out the AM broadcast band, and one to block out the FM broadcast band. And with two of those, I find that to be really useful. The version 3 is good of that particular RTL SDR dongle, because it allows you then to directly sample the Q branch and then actually cover all of the HF band, which is the areas of interest that I'm interested in. So that's really good. Oodles of free software out there. I just settled on SDR Sharp. I've been using that for a long time. It works, and yeah, it's fine. In terms of SDRs, another useful tool is the online SDR receivers, the Kiwi SDR and the like. I use those all the time. One just across the strait here, one up in Auckland, and then one over in Australia. I look at all the time, so just to get those varying distances. Yeah, that's another really useful tool. We do live in a really interesting age these days with the internet, and just having these is just great from a homebrew point of view, being able to utilize these things. So that's the SDR dongle. I just mentioned before, just be careful of overloading those. What I do tend to do is just have a little short piece of wire stuck in the BNC plug there, and that's enough just to sniff whatever radio I'm playing with that's transmitting to a dummy load. If I need to extend that just a little bit, I can. But that way, I tend to keep well within the range of what the receiver is set up for. Which then brings us now into enclosures. So as Neville pointed out, and I'll freely state, I have pulled a lot of things apart. I'm very keen to see how things work, and virtually anything I build around here, most things I build around here, it's all open and on display. And the reason for that is I just get so much enjoyment myself from being able to sort of see into the radio or whatever it is, and actually saying, okay, well, that transistor there, that's part of the IF amplifier. That switch there is switching this, or that wire is linking here to, whatever it is. I just really enjoy, as I'm using the equipment, actually seeing what each of the individual components do. So invariably, as you've seen many times on the videos, the radios are built on breadboard. I just use an expensive MDF, that sort of squash wheat bix board, and just screw directly, just using some small screws, the copper board directly in. So I've got a drill always on hand here, just drill a couple of diagonal corners, screw the copper board, as you can see there, directly down onto it, and off we go. Those vertical brackets I talked about, they're also screwed directly onto it, and then things are connected up. That just sits up on the shelf for those that are still surviving, and just throw a tea towel over it just to keep the dust off. But it's, each to their own, and I enjoy that particular approach for the base rigs. For the portable rigs, the ones that sort of go outside the house, I've sort of settled on using food containers. We have a range here in New Zealand, the Sistema range, which I sort of predominantly use. So I'll flip them upside down and take off what is the bottom to expose the top, which we'll see in the next slide, to then mount the radios in. So in the closed up state, for me, it's just really good. It's nice and easy to throw in the pack. It's dust proof, it's waterproof, and just works well. You do have to take the covers off, so to speak, to use them. But as I just said before, I enjoy looking at the radios, so that's no hardship for me. And I'm certainly not going to be outside playing around in the rain, so no problems there. So as you can see there, that's with the covers off. Yeah, what else to say really? You can sort of see the range there of the sort of simplistic user interface, just a simple screen, be it the old 8s there, or the small OLEDs, the 16:2. The one on the very left was just telling me what channel it was on. It was a channelized radio just by blinking an LED. And you can sort of see the various brackets holding bits and pieces on. Mainly for PTT, just as I've just sort of spotted it there, it's just a simple slide switch, which I tend to use, double pole, double throw slide switch. So one half does the voltage switching between the transmit and receive, and then the other pole does the RF, and that's worked well. Again, the transmit side of the house, which is, if you're looking at the radios, is predominantly on the left, is separated from the receive part on the right by a full-size shield that runs between the two, and that has worked well. And where I need to, just a few small holes through that particular shield, passing RF and VCC around the place. So so like I say, that's a little bit unconventional, but it's something that works for me. It's cheap, it's easy. The copper shield there is literally, there's no wooden board under that. It is just the copper board with the modules on top, and that just sort of sits inside. Two different approaches I've taken there. I size it that it's an interference fit into the lid, so it actually stays there nice and tight. And in one case, I actually did drill through and mounted with just some small screws, machine screws it is. Both approaches work. I have more recently decided to have a play around with an old commercial rig, using that as a chassis. In this particular case, it was just more a bit of an interest to try and use a lot of the I/O, a lot of the actual switches that came with the radio, just to have a bit of a play around with that. The downside, of course, from my point of view, is once the cover's on, I can't see inside. I'm just looking at the front. So each their own. But that was quite a fun little project, that one, sort of like I say, interfacing with the existing switches to provide the various switching and the like for the radio. So that's pretty well the enclosures. Just all want to finish off with a few sort of other projects. I elected to throw this into the presentation. I guess it's just not all radios and that, and building test equipment and building other parts of the shack is certainly useful. And in terms of homebrew, just give it a go. If I can do it, anybody can. So this one, particular one here, was a power meter and an ATU. That particular power meter, I mounted inside it on Antoid's, the old mince tin. It's an 8307 logarithmic amplifier. And then that was feeding some signals into just a simple Arduino with a 16:2. It's a tandem coupler there, just to provide the sense voltages in a die-cast box. It was quite a fun little project just to play around and do that. The bottom one there is again using another plastic snack box, same arrangement. The ATU itself is mounted in the lid with the top coming on and off. That particular one there was for an end-fed half-wave antenna for QRP. So the capacitor itself is just a small, as you see, of AM radios and the like, the polyvariable capacitor. The meter there came out of some old, I've had that for a long time, some old junked military bit of kit. I think it was a 1 milliamp meter, which I was using as a strength meter for dipping for the match. But yeah, that was fun. It was good. Another thing I was playing around with a while back was an antenna analyzer. So in this particular case, it was an 809850, being driven from again an Arduino. This particular case, I wanted to try around playing because I hadn't before with the number keypad, how that would work, and I used that for the longest time here to tune up antennas. Later on, just to have a bit of a play around, added a very basic scalar network analyzer to it, again based around the ADD, so again the AD8307 feeding back. So there was a simple switch that the output, the amplified output of the AD9850 either went left to go for the antenna analyzer or right to the SNA, which was quite good. It was quite a fun little project. Another one here was another antenna tuning unit, but in this particular case, I sort of decided to throw into it at the same time an antenna analyzer. So the whole idea of this one, and it's got the tuner as well, I should say. I think I just said that. So the whole idea there was to tune up the antenna using the analyzer, then take the analyzer out of circuit and just have the tuner going straight into the radio. Yeah, it was quite fun. Again, just as you can see there, in this particular case, it was on the bottom of that particular little lunch container and not on the lid, just a slightly different approach. But yeah, sort of fun. I don't know if I mentioned it before, but I know Pete Giuliano's mentioned it. We live in a really great age where we can purchase through the likes of AliExpress and other online shops some really inexpensive modules and components. Be it the SI5351 or the AD9850 or those little OLEDs. For not a lot of money, you can get a whole lot of capability, and it doesn't take a lot to put them together, and you can make some really interesting bits of kit. Yeah, really interesting time that we live in. In terms of other projects, I do enjoy clocks. I've built a number of clocks over the years. I started with digital clocks, but I just don't really enjoy the digital display. I really much prefer the analog display. So most of the more recent ones are analog displays. In fact, the digital one up there using the Nixie tubes was quite fun. There was an old military frequency counter. So managed to score the circuit diagram for that to understand what the various chips were, and then basically pulled the whole thing apart, desoldered it all apart, and then reused all the components for a clock. It sensed the mains frequency, had a 10 hertz Nixie, and then that sort of trickled down and did the rest of the clock. So that was quite good. The clocks these days are pretty well predominantly GPS controlled. Just sort of interrogate the RMC word and sort of pull that apart and extract the time that I need, and then just write some code to draw a circle, draw some radius, draw another circle, but make it blank to create the minute and the second hand, again, marks and the like. So yeah, it's always been of interest to me. Did have one office where the windows had a film over them, I think, to keep the UV out, which also blocked the GPS signals. So that was a bit of a pain. So there's a couple of clocks now which have been built using the DS3231 real-time clock, which works well. And you'll see there, sort of quite like using quirky enclosures. So in 2 of those cases, they're old 35mm slide viewers, which is sort of quite nice because the front magnifying glass sort of gives it a bit of a an old-fashioned CRT type look to it. It's quite effective. And one of those is actually an old flash, an old camera flash, which has then been gutted out and then just sort of use that to a bit like a TV set. Had also been playing around with the Raspberry Pi, very capable single board computer. I'm sure people are well aware of its capabilities and what you can do with it. In this particular case, it was more recently been playing around with that, sort of looking at some of the digital modes, FT8 or the JS8 call, and just sort of making a very simple audio interface with the radio using a couple of audio isolation transformers there just to break up those earth loops. So yeah, quite good. Again, just very simply mounted to a wooden board there, nothing flash, just driving a couple of screens. Yeah, it's not, yeah, just different things. I think I put a video up about this one here. This was a little whisper transmitter, had a spare 20-meter antenna that wasn't being used that often on the roof. So sort of just had a little dedicated whisper transmitter just sitting there, transmitting into that. I think we're looking okay for time. In this particular case, I hard coded into the software where I was in the 2 power levels. So had 2 different power levels, a high and low, so to speak, and it would just sort of transmit the word. And there's a simple series of LEDs on the front, sort of indicating what percentage through the 2-minute transmission cycle was at. Was it a high power or low power signal, and the like, and then just what code it was of the four codes. Yeah, sort of mounted that in an old clock case. Quite like that one because it sort of had a bit of an Art Deco look. Yeah, quite fun. And then I guess finally, what I had always been playing around with because of the sort of love and radios was just a shortwave radio receiver. This particular one, I decided to have a play around with an analog VFO. It's for the 49-meter band, shortwave band. It was a bit of a hodgepodge radio, so for sort of, I guess, from front to back. The front was a tuning capacitor out of an old radio, which was no longer used. So again, sort of trying to reuse parts for that. The Colpitts oscillator, using a number of J310s, because I've got a few of those sort of lying around. The actual VFO case itself is again made out of that copper board, cut down and then made into a box. And then out of one of those junk radios, you'll see quite often those, as you can see there, that tin roof that sits on top for shielding. That sort of sits nice and snugly on top. Had a commercial AM 6 kilohertz crystal on that one. The mixer itself was an SPL1 and an infinite impedance detector for the AM. So quite a fun little project. Again, mounted on the wooden board there. So yeah, there you go. Quite fun. Anyway, another saying that I say quite often because it's true. I think I've probably rambled on long enough. Hopefully, it was a bit of a romp through the approach I take, but I'm kind of hoping that what I've presented sort of shows that you don't need to have a lot to do homebrew. It's very easy to get into. It's very easy to source the parts. As you'll see from other presenters, you don't need high-end test equipment at all. I don't have high-end test equipment. And I guess to sort of recover the caveats at the beginning that this is very much my way of doing it. It's a way. It's certainly not the only way.
Hey Charlie, we love your way. Don't make apologies.
Well, yeah. Okay. Well,
I'm conscious of the time. So I'm not wanting to cut you off, but I'll get into all sorts of trouble if 11 o'clock rolls around, Charlie.
Please do.
It's meant to be question times. There's a couple that have popped up, which I'll quickly throw at you. Just to let you catch your breath, if I can just make a couple of comments. There was quite a few comments from people about the condition of your shack being way too tidy. So if you could do something about that to take the pressure off the rest of us. The stripboard stuff to you is quite unique, and I just bring to other people's attention that you did a series on your YouTube channel of how you did them, and that's a really useful series. I'd also like to acknowledge you just touched on the Teensy, and I don't know if people realise you did some really revolutionary work using the Teensy and the audio shield of the Teensy and the Hilbert transforms. And again, people go and look up Charlie's videos on that. He was literally breaking new ground in the world of SDR for ham radio. Probably my final comment is your plastic food containers. For those that have been around a couple of summers, it's just another nod at the famous Tuckerton 2 and Tuckerton 3 series from New Zealand. I'm just putting a plug in for our hometown. One of the questions popped up, Charlie, was places to get bits and pieces from in Arley. Do you tend to have a favourite place or a favourite seller? You probably don't want to ramble on about it, but you like most of us, you choose one and just run with it.
Do you want me to unshare, or what's the best way of doing here?
Yeah, no, you're live still, buddy.
No, shall I unshare the presentation or not?
Oh, no, you're right. You're right.
Okay, we'll just leave it there. Yes, I do have, no, I don't have a set number of buys that I go to within AliExpress. I do have one saved away, which I have for the copper boards, but generally speaking, I'll just go and find what I want. I'll sort it by...
What you could do there perhaps is send a link through to Nick or something like that, and he can put it in, as they say, the show notes.
yeah, exactly.
And ditto, there was a couple of people were asking about the engraver that you use, or CNC engraver. Again, if you could give us a link for that one, because there was a bit of interest there. And the third one was, and it's one that interests me, was about sources of NPO capacitors. So if you might like to throw that at the powers that be, if you've got some good sources there. Now, I had some questions just to keep the ball rolling, but I've got Nick in the background telling me he's going to break my neck if we run over time. so I'll thank you. We're only a few kilometres apart, Charlie. People don't know that. We're on different islands of this great country of ours. But it's been bloody good of you to come on tonight and share New Zealand's take on homebrew radio, G-QRP radio. All of us appreciate your work. We all appreciate your YouTube channel. And with that, thank you very much. And Nick, if you'd like to steal the show and do whatever you do. Cheers from ZL.
Okay, guys. It's Steve here. Nick's having some computer problems. I hope you can all copy this. So thanks from me to you, Charlie, and to you, Neville, for a great session. And we'll end this now and hopefully rejoin the session in about 5 minutes time for the next presentation. I'm sorry we can't keep it running for much longer, but lots of appreciative comments coming in there. So 7-3's Charlie and Neville, feel free to stay with us, but I appreciate it's probably getting later down there. So 7-3's from me.
Yep. Okay. Cheers, Steve. Cheers, Charlie. Oh, hi, Paul out there. Thanks for the messages, Paul.